So this is project log for the floor curling or the electronic floor curling broom redesign. I think it's part 6 or 7, something like that. Haven't been here for a while. I was waiting for the feedback. Now my client who ordered me to redesign this, he actually sent this broom to one of his customers in Canada, who runs like another sports shop, I think. But so as you can see, this from this picture, you might be like, oh well, you messed up. And yeah, I did mess up on the joint. I'm currently working on another variation. So as you can see, this broke at the layer seams. So when one layer meets another, that's where it broke. I'm trying to print it horizontally, that way the layer seams are a lot larger, or well, a lot wider, and so they're less likely to break. But that's not why I'm filming this right now. The reason I'm filming this is because the feedback that he got was actually mostly positive, despite this picture. You know, they really liked it. Well, they didn't like it, their kids liked it. The kids who used it in class really liked the product, and so they saw a lot of potential. And so they said, if you can fix the durability problems and the freeze problems, which apparently are still, you know, very much there, then they can actually, well, they would, you know, be inclined to buy some of the broomsticks. So I'm doing another redesign here. As you can see, this is 1/2 side of the joint. You know, it was initially one piece and I printed it this side down, but now the way I'm printing it now is like this. So as you can see, we have two pieces of identical height, except one has the hole, or the pinhole, on this side, and the other one has it on the other. So that's really the only difference. Actually, now that I think of it, aren't these two identical? Wait. Are they? I think they are. Why did I export them twice? Yeah, they are identical. Okay, well that's... I'm a bit jet lagged right now. I'm coming back from Laos. So maybe that was it. But basically they have these cutouts in the bottom here where this piece fits in. So I've tested the durability with this prototype that I've made here. It's really messy because I couldn't figure out how to make the supports tidy, but I fixed that. We now have minimum supports, and I cut down print time by about 13 minutes. So we should try with this again and have similar results to this, which is very promising, because these did not break even when I hit it with this hammer. You know, it's not too much force, but it's a lot more than, you know, you'd need to expect. The goal for durability right now is when you smack or throw the broomstick, the shaft, which is probably carbon fiber or aluminum, will crack or dent before any of the plastic parts break. That's the goal we have right now. So really the only other part than this that I think, you know, will impact durability is this joint, well, this axle holder, this one that fits in. Okay, we're a bit blurry. Yeah, this axle holder that fits in right there. I call this an axle holder because this hole right here, that's where the axle will fit in. Where did I put that? Yeah, so this part is metal. It's stainless steel, so there's no way this thing's breaking. But as you can see, this is a pretty small part, and I'm worried that this part right here might break. So that's what I'm worried about right now. But so if this ends up breaking when I do another joint test, then what I'm going to end up doing is I'm going to change this part out with a CNC milled piece of aluminum, which I think it's going to be simple enough because it's so small, but we'll have to see. And then I'll just work on the sizing of this a bit. I think it won't be too much more expensive, and it will definitely improve durability leaps and folds beyond what we're used to now. So that's that part. I really wish I could just make this one piece, like this cross one piece, and just fit that in there. So I really hope I can make this cross just one piece and then fit it inside this plate. But the problem is the joint's jam-packed in the middle, so I really can't do that. I could do a redesign where it's just a one-sided joint, but given how it's plastic and given how, this thing's going to go through a lot of impulses and just pressure, and not pressure, but it's going to be, it's going to experience a lot of impact when it's being used. I wouldn't trust a lopsided joint for this. Maybe there's a better design. I haven't found it personally. If I do end up finding it by some random other method, I'll definitely be inclined and very open to adapt that joint. But for now, this is what we have. This bottom plate is, as you can see, this thing doesn't really break. It's difficult to break, even more so because there's another, I think it's this one. Yeah, there's another plate down here, and so these two hold everything in check. So the durability problem really doesn't arise here. The other thing I'm trying to fix is it's actually a problem caused by friction between parts. Is I made this part to fit really, really, really snugly with this stainless steel rod, and the problem is when some impact happens and this shaft moves, well, it's not supposed to move, but it can move this way because it's open, and when it does move that way, and the shaft kind of slides out like that, and so that's a problem. So I thought, why not just make the shaft a bit shorter, fit it in here, and then I can just make a pin or a bolt system, and I'll just bolt it here, like right there, and then that should be good enough to hold this stainless steel rod in place. So that's another step for durability. The real big key differences that I'm planning to make here, well, they're not big compared to version 1 coming to version 2, but they're still substantial in my opinion. The other part that I'm worried about is the button. I'm not really worried that the button's going to break. Yeah, that's kind of difficult to happen, seeing as how the button is super far. Why is this not focusing? Do I have to, zoom in? Can I do this? Yeah, okay, I'll do this. This is, I would say this is better. But, given how this entire platform is around the top of the shaft, which is a meter and 2/10 above this entire contraption, so I'm not really worried about any of these parts breaking. Rather, I'm worried because of the space that the button has. It might wobble around a bit. That's what I'm concerned about. Okay, that's not what I want. No, that's not what I want either. What is going on here? Okay, yeah, so this is the button part down here. And so the way it's fixed right now, okay, we're gonna have to remove you and you and you. Okay, so the way it's fixed right now, as you can see here, is we kind of just shimmy it in and fit the board with the PCB and the Arduino in like that. And I don't really have too big of a problem with this because the pipe or the shaft, the hole in the shaft ends up fixing this in place. But that's not really ideal because, it can jiggle around and, touch things and, maybe hit the pause button. That's really not ideal. So I'm going to try to make another kind of anchor design that's shaped kind of like this to hold the button. So that's what I'm going to be working on next. And the final part that I need to work on, or second to final part, is the PCB. Right now I'm fixing it inside of this slot with glue. So if you come down here, not there. There we go. And no thank you. No thank you. Okay, if we come down here, we can see that you can kind of see this this thing right here, you know, like this. That's where the PCB fits. The problem is, as you can see, there's nothing that holds the PCB from just scooching down the shaft other than the super glue that I use. And it's also not ideal to use super glue because if I have to fix the code or whatever, or they have to remove the PCB, that's impossible if I fix it with super glue. So my idea is I'm just going to elongate this part and use the same pin method to just hold the PCB in place. That's what I'm going to do. So that's the second to last part. This is the last part that I plan to work on, is this top part, and it's really a simple fix, at least I think it is. The problem that's happening right now is that every time there's a big impact, the batteries jiggle around in there, and the contact patches, they lose contact. And you know what that is. It short circuits and boom, it turns off, resets everything. As I said, it's not ideal. So what's the plan then? The plan is initially, and it still is, to use stronger springs to hold down the batteries. But the other part of me damn it, I tried to do that last time when I was fixing the redesign. What ended up happening that time is I redesigned the spring to make it exert a larger force. Jesus, I'm tongue-tied. To make it exert a larger force. But the problem was, if I just kept the spring in there, just compressed for like a week or two, it would just stay compressed. And you know what that is. With cheap springs, this happens a lot. So if you keep something compressed, it just won't be elastic anymore and return to its initial shape. So that's definitely not ideal, and that's definitely not what we want from this contraption. So I'm thinking we either do a redesign here or use a more reliable spring setup. I also plan to reduce the space that we give the batteries, so that way even if the spring is compressed and it stays semi-compressed, it can still function as a tool to stop the reset and the shutdown. But yeah, so that's the plan for now. I'll film I'll film another project log for every problem I fix, starting with this. We haven't fixed this yet. So we have 3 problems: durability, the switch, or durability, repairability, which is the switch and the PCB, and functionality, which is this top part. So I'll finish each of those, and then for each of those I'll film a video reflection. Or not video reflection, I'll film a project log. Okay. Anyway, have a nice day, have a lovely day, and goodbye.